Number of different things, but films is part of it.
Right. And I was away when this was organized. I was given his name and number by a former student, and I contacted him after about a year. I think she had given me your card. And suddenly I kind of realized what it was I was holding in my hand, which is something very, very interesting. And then I had to leave. I was out of town for about 3 weeks. And so Patrick is the person that actually set this lecture up. And so he went to his studios and looked around, and he knows a lot more about this man than I do. So I think having said that, and inviting you now, the lecture series will continue every other week. I'm hoping to get a person who's an expert on bamboo for the lecture after this one. And she's actually a world expert in all the uses of bamboo around the world. And then after that, the Vice President of Imagineering in charge of design will be coming, I hope. All these things depend, like in Sandeep's case, I'm looking they're out of town, all kinds of things can divert them, but we've got a really interesting program for the rest of the term. And the walkthroughs will be starting. I'm sorry that they're so late in getting going. It's totally my fault. But the first one will be a walkthrough of Michael Rotundi's Carlson House. And it will be with the structural engineer, Amanda, who actually made it possible. I know all of you have probably seen it because he's had receptions there. And as you know, it's a sort of a suspended structure inside a shell. And the engineering on it is really the key to the whole thing. Michael will tell you that. But the engineering on it is very important. So we're going to do a walkthrough of that structure, I hope, sometime in the middle of this coming month. It just depends on when the engineers are ready. Michael won't be there. I told him he couldn't come. So in all these cases, when we do the walkthroughs, we don't do it with the engineer, with the architect. We do it with the engineer who actually supplies the construction, so that you can find out how things really got put together, how those problems got solved. I hope after that we'll get a Frank Gehry building, although Frank is really resistant to let us go without somebody from his office in there. I'm trying to go in through the back door and just go through the engineers themselves, so he doesn't have to worry about what we find out. So that's sort of what's coming up. So with that said, Patrick, do you want to please
I met Sandeep Monday, and he brought me through his office the other day, and I'd never met him before, and I really didn't know much about him or didn't know what he was about. But when he brought me through this place, I was totally impressed. And he's got 14 architects, 18 architects working in the office, and he first told me that they create virtual spaces, and that's, so I didn't really know what was going on, but I just couldn't believe the range of things that they do there, and it goes from creating architectural spaces for commercials and movies, and also he's experimenting a lot with motion detectors and putting that, using that for interactivity on the computer, and it was just totally impressive. And I think you guys will be equally as impressed. So with that, Sandeep.
Well, thank you. Patrick's been very kind. I actually went to SCI-Arc back in 1985-86. I was studying urban design at the time, and after that I got interested in computing. I've studied architecture since 1980, and I went to the University of Bombay, and then I went to SCI-Arc, and after that I went to the School of Architecture at UCLA. And that's where I got interested in computing. Back in 1986-87, we were actually doing computing in architecture, doing graphics on these really ancient machines called 8088s, which none of you have probably even heard of. But it was interesting to me at that time. We were doing experiments with things like shape grammar, where you could break down architecture into rules and then use those rules to recombine elements to create new architecture or new spaces or new structures, etc. So anyway, that's sort of what my educational background is. And when I graduated, this was the time of the real estate boom, late 80s. A lot of office buildings were being built, strip malls and all that sort of thing. So I worked for a few years doing a couple of different things with computing related to architecture. I was building 3D models of the Great Western Bank complex that's out in Chatsworth. And we devised a new way of tracking all the assets that were owned by the bank, such as movable furniture systems, lights, etc. And they were all built in 3D, so an engineer could come through and figure out, okay, this needs to be repaired. Let's take a look at it here and figure out before we actually go out onto the site. Saved a lot of time. We also devised ways of tagging assets so that the accountants could go in and depreciate things, or you could also figure out when a light bulb needed to be replaced if its life was, 1.5 years or what have you. So from there I jumped to doing 3D animation for a real estate developer in Beverly Hills. So this was back in 1989 when 3D computing was just starting to come about in the architectural profession. And we were doing real-time walkthroughs at the city of Beverly Hills because this developer would buy all these really expensive tracts of land in Beverly Hills and try to put up these condos, and you had to get it in front of the Architectural Review Board in Beverly Hills, which was very sticky about a lot of things. So you had to keep getting back on the agenda until you got the design pushed through. So we would actually take these computers down to Beverly Hills City Hall this was in 1989, and walk the city council through it live, which was probably a first. I don't think it was ever done before. We simply didn't have the computing power at our resources to be able to do something like that. Well, that was the good old 80s. The 80s went away, and so did real estate, and everything went into a tailspin in terms of the real estate market. And at that time, I thought to myself, what can I do for a living? I can do 3D computing, I can design, I can visualize in 3 dimensions. There isn't a job for me as an architect. What am I going to do with myself? So at the time, there was a couple of articles on how they were doing these 3D things for commercials, and somebody had built a 3D city. It was a company called Optimistic Studios. It was an experimental thing. So I called them up, and they didn't have a job for me, and so finally, somehow, I managed to get a hold of the phone number of a gentleman called Charlie Gibson. Charlie is one of the founders of a company called Rhythm and Hues, which is actually a couple of streets over now. I don't know how many of you guys know of the company. But Charlie actually won an Oscar last year for his visual effects work on the movie Babe with the talking animals. So I got a hold of his phone number, and I called him almost every day for 2 months until he got tired of me and said, you know what, I can't give you a job, but I'll give you a reference. So that's how I got started in the entertainment industry. Got a job with the company, and my first job was to build a model of the Magic Castle up in Hollywood, where it was for a show opening on CBS. This was back in 1989. So that's where I entered the whole world of entertainment. And at that point, I realized that things were getting more and more complex in 3D computing for commercials and film. And these people hired me because they couldn't figure out what these plans were all about. They couldn't figure out this complicated system that was a building or a structure or a space. And that's why I got hired. And so I had that in the back of my head, that there was going to be some sort of a future for me here. And I finished that job, and I worked in a couple other places. Then I got hired in 1991 to work for Kevin Costner. I worked for him for about 1.5 years on a documentary called 500 Nations, which was on CBS in '94. And we recreated 3 ancient cities in North America. And we were able to actually depict them as they might have looked in the 9th and the 10th centuries. And that project was sort of a groundbreaker. Nothing of that complexity had ever been attempted before in 3D computing. A company called Santa Barbara Studios did most of the visualization, where they used a physics-based system to actually show fires and smoke and things like that. So when you actually walked through this town, it was real. And I worked with archaeologists at the Fowler Museum at UCLA and several interesting art directors to actually recreate some of the artwork and the statues, and to see what all of this might have looked like back in the 9th century. And we used National Geographic as some references. We actually used satellite imagery as other references. And some of the cities we constructed actually differed from National Geographic's own research because we had much more accurate information using the computers. And so when we finished with that, at that point I went back to 2 of my friends that I'd met in the real estate industry, and they were both architects, and they had their own architectural practice at that time, which wasn't doing that great because things were very, very slow. So I said to them, look, let's put up some money. I see a future in all of this. Let's go ahead and do this. So in March of '93, we started our own company, and that was 3 of us working out of my partner's studio apartment out in Culver City, right here, down on Centinela. From there, from 3 people in '93, we have now grown to almost 18 people here in Los Angeles, and we have another 12 employees in India, and we own a piece of another company in Israel that used to do defense simulation for the Israeli Air Force. So most of the people that work with us are architects, and but we also have a lot of other diverse talents that work for us. Engineers that can build circuit boards. We have sculptors that actually create creatures. We have programmers. We have graphic artists. It's almost like the more high-tech you get, the more towards a Renaissance model you go towards, because you literally need all these different skills. And I'm going to show you some of our work so you can sort of fathom how all of this goes together. So can we cue up the tape? The first tape that we had back there? Many of the things that you'll see on the tape you will have seen before. So, and after we run through the tape, then I'll explain to you what is it that we've done. Yeah, there is sound. You could turn it up.
Turn up the sound. Can we dim the
Yeah, we can turn the lights on again. So you're probably all wondering what that tape was all about and what we had to do with it and all of those things. We found out as 3D computing got more and more involved, people couldn't really make all those objects that you saw in there. The first, the tape opened with a set. And that set is actually the set that was used for the new Terminator 2 ride at Universal Studios in Florida. And what we ended up doing, we worked with the director James Cameron. That was the last act of the 15-minute movie. And what you saw was one screen and there were 3 screens above it. So each screen is actually 23 feet high by 50 feet wide in real life, and they're at 60-degree angles. And so they had us build a set, and then they composited the live action over the set. So Arnold Schwarzenegger and this kid go in and destroy that thing in the middle, which is this evil brain that creates all these things that destroy humans. So one of the reasons why they wanted to build computer sets for this was they actually experimented with a real set, and they found that when they filmed it, especially with the large format film, that they were getting a 3-point perspective. And so it's real, but it looked really odd for the format they were using. So what we ended up doing was working in reverse of what the Greeks did, you know, where they built these temples with the columns played out so that they look straight when you viewed them from afar. And we went the other way in terms of that project. So what we found that there was a huge market for people like us that could visualize complex spaces and then actually put them together. So we were actually design build, you know, we're designing these things in association with the art director or the director of the film or the commercial or what have you, and then actually constructing these sets together. So that sort of gives you a background of, you know, how it may also be a surprise to many of you that most of the cars that you see in car commercials are not real cars. They're all built on the computer. We actually go out onto the set and we have something called a coordinate measurement system, which is actually works on the principle of a radar signal, where you shoot out a radio signal through a probe and it bounces the position of the point in XYZ space back to the computer, and then you can register the point. And it's more or less a high-tech game of join the dots. You know, you put all the dots in the car and then you connect them all up together and then you have your object. It's not quite as simple, but that's the general principle. Anyway, so let me talk about what all of this means to all the architects and architecture students that are in schools today and all the architects that are out there. I actually am on the visiting faculty at the School of Architecture at USC. And I've been teaching there for about 4 years. The dean actually met me and he saw some of the work we did, and he felt that the students in association with the cinema school really needed to be exposed to some of the new avenues for architecture that were available with all of this technology that was expanding our reach. So there's an annual conference which has been going on for the last 26 years. It's called SIGGRAPH, and SIGGRAPH stands for Special Interest Group in Computer Graphics, and it's a division of the Association for Computing Machinery. This year will be the 27th annual conference, which will be held in Los Angeles. Those of you that are here in the summer, I would strongly recommend you go, because it's a very interesting place. It's not quote-unquote computer geeks that come over there. It's more, there's scientists, educators, entertainers, artists, military people, medical people. It's a meeting of the minds of everyone that uses computer graphics to enhance their work. And it's really amazing because you have all these people from very diverse backgrounds sharing some pretty amazing things that they've done. So in '94, I attended a conference in Orlando, in Florida, where there was a panel that was put together by a friend of mine called Roger Wilson. And Roger is a very well-known person in the computer graphics industry, and he graduated from SCI-Arc back in 1975 or 76, some year like that. Just kind of interesting, you know, because I keep running into all these old ex-SCI-Arc students that are in the computer graphics industry from back in the 70s and 80s. So Roger put this together. The other two people on the panel were, other three people on the panel were Dr. Brenda Laurel, who is a researcher at Interval Corporation, which is owned by Paul Allen, and they do a lot of research in virtual reality and human computing interfaces. The other person was Dr. Leonard Schlane, who's a surgeon, and the third person was an interesting gentleman by the name of Dr. Terence McKenna. And Terence lives in Hawaii, and he's done some research on, he's a psychologist. And his main theory is that man evolved from the monkeys because some apes somewhere ingested magic mushrooms, and they sort of had this leap of of perception, which, you know, you may or may not agree with it, but what he was trying to say was, we're at a point in our history, you know, in the last 50 years, technological development has been at a very accelerated pace. We had the atomic age, we had, you know, the space age, and now we're in the information age. It's been very accelerated, and so the advent of 3D graphics is sort of making us evolve in the way we communicate with each other. You know, you had the cave paintings where the cavemen communicated, you know, their ideas through you know, abstracted paintings that they drew on the walls. Then we got to the spoken word, the written word, and now we're back in 3D computing where we can talk to each other, you know, using graphics again. And it's sort of an interesting way where this is going. But one thing that they didn't talk about was the fact that there's some professions that are also evolving and changing as they go along. You know, the job of a web designer, you know, this is a brand new function that wasn't even existing 4 years ago. You know, as early as 94, there was no such thing as a web designer. Well, today you have legions of people that are making all kinds of money, you know, doing web design. So the point that I'm trying to make here is that the profession of architecture is also going to evolve, or is evolving rather, to change with this new technology. You know, architects now can do walkthroughs and 3D design presentations of their work. On a parallel course, you know, you see all these 3D games out there on these video consoles, the Nintendo 64, the PlayStation, and 3D computer games. You know, that's what you keep seeing in the consumer end of things, where you can actually go inside into the computer environments and interact with objects and things. So all of that is saying that we're moving more towards spatial experiences in not only our entertainment, but in the way we interact with each other in terms of communication. The World Wide Web is probably the biggest opportunity we have. You know, everything was two-dimensional for a couple of years until '95, when a gentleman called Mark Pesce and Tony Parisi came up with a standard, just like you have HTML for the web, you know, hypertext markup language. They came up with a standard called VRML, which is Virtual Reality Modeling Language. And it's a standard that will work the same on your computer as my computer, as somebody else's computer, so we all see the same thing. And all of a sudden, this was a way of transmitting 3D graphics and interacting with other people in 3D graphics. I don't have exact statistics, but I've been in the computer graphics industry now almost 10 years, which more or less makes me a veteran. It's scary, you know, there's people that are 23, 24 years old that have been doing this for 6, 7 years, ever since they were kids. And a lot of the people that I know, that I've worked with, my colleagues in the industry, they all have, either they were architects, or they have architectural training, or they have some kind of architectural background. And when you think about it, it's really not that surprising, because what is it that we learned as architects? We learned how to conceptualize three-dimensional spaces, and then we learned how to transmit those ideas and communicate those ideas to somebody else. You take somebody else's desires that they verbalize, then you put them down on a means of communication, traditionally that's been paper, and then you communicate that idea back to whoever it is that you're working with. And it's an experiential art. So as more of these entertainment applications, like the ride films that we talked about, the computer games like Doom. Anybody play Doom here? You know, you go through these spaces and you're shooting up people. That's one application of it. But it's all about experience. And that's what we learn as architects, because you don't just design a space, you design the space to be experienced. You walk through it. There's motion involved, there's lighting, there's all of these different things that also have to be done. Well, you can do them in real life, but you also have to do them in cyberspace, because it's all about the experience. Because there's another law called Gordon's Law, which I'm going to pay the gentleman a royalty. Gordon Moore is one of the founders of Intel Corporation, which almost everybody is familiar with. They make all the microprocessors that make, you know, all the pieces of the world work. But Gordon Moore, back in 1965, came up with this theorem that the cost of computing will drop in half every 18 months, and the performance will quadruple every 18 months. And we have seen that law since 1965 take hold. And that's where we are seeing the quantum leaps now in the 90s of performance. Today we're able to actually do 3D animation over the internet. What does this mean to you and me? Well, the internet is sort of taken over as a means of communication. In '94, the internet wasn't even in my business plan. Today, it represents one of the biggest sources of revenue for me. And not only that, it's also one of my means of communications. We have subsidiaries in India and Israel. We communicate with them over the internet. It's a huge cost-cutting measure because I'm not paying for $2 for the cost of a phone call. I can log into a chat server. We found this open chat server. The Grateful Dead have this free site that you can log in and have a chat server. So we have the people log in every evening at 6 o'clock. We're on a 24-hour day because there's a 12.5-hour time difference on the other side of the world. So they log into this free chat server, and then we can have our conference about our work on, and it's free. So there's a lot of interesting ways you can exploit that. But the long and the short of it is that all of you as architects and architectural designers are going to find this an avenue that you're going to increasingly explore. We just finished a game for a director called Steven Spielberg, again, who everybody's familiar with. It's called Vertical Reality, and it's been, I think there was an article in Business Week about it last week, and it was on the National Public Radio that talked about it. It's a 3-story game where you go up and down and you shoot at these characters, very beautiful environments. So we got these concept sketches from Spielberg's office, and then we created this 3D environments and beautiful textures and lighting, and that's sort of the experience. So once again, you've got a film director involved working with architects, because not only now are you talking about a space, but you're talking about movement that goes along with the space, movement and lighting, which are the other two critical components of architecture. It doesn't mean that this whole process of 3D visualization and 3D computing isn't useful to you as architects, because if you can visualize your work along with all the materials and the lighting very accurately, you're going to come up with a better design. What do you do when you have extra time left over? You spend more time designing. So you have better and better tools to deal with it. Not only that, but you're being forced to go towards 3D computing in architecture, because many city review boards are demanding to see 3D computer-generated renderings. There's been several lawsuits that have dealt with the aesthetics of a built design differing from what was shown in watercolor renderings. I remember when I was in architecture school, if I hadn't quite worked out something in the elevation and the perspective, I'd draw a tree over it so that disguise it. Well, you can't really do that with computing, but we've all been there. And that was that brings me to another interesting point where I did a presentation to the Thousand Oaks Civic Center for a design that was done by Antoine Predock. I'm not sure if you'll know the project. It's the Thousand Oaks Civic Center. It's got a big wall that's on the 101 freeway. It's interesting because I took my computers down there. This was back in 1991, and I was being paid by the executive architects to do this presentation. So I had this whole thing set up, and I was going to drive down the freeway and show the city council what it looked like. And it's funny because they told me, under no circumstances should you show them the views from the freeway. So that was my instruction from the architects. So I got there, and I got there early. Well, I want to see what you got there. So, well, I can't really show it to you because, I don't know who you are, and you're not paying me, so I'm not going to show you anything. So I waited till everybody got there, and then I had to steer the city council away from those views. It was interesting because a year later, or 2 years later after it was built, a lot of controversy erupted about the view from the freeway. And so that tells you it depends on who's writing you the check. You can't lie with these things. So you really have to be careful about showing these. People use that in courtroom animations all the time, and the computer is very accurate simulation. So depending on who is paying you, your presentation can be skewed. So that's just an aside in terms of ethics and things like that, which I don't want to get into. So where is this all going? A lot of us are going to be doing. There's going to be whole new job categories where the October '92 Hollywood Reporter had what they call the digital call sheet, and they actually, I'm going to read from my notes here. One of the descriptions was that of a digital architect, and this was back in '93, I'm sorry. The digital architect position developed because so many interactive games use material that is a composite of live action and digital sources. The digital architect is a 3D animation artist and an architect whose responsibility is to make the digital world that is created on the computer screen match with the live action footage that is shot against a blue screen. This type of coordination involves the modeling of physical space, modeling furniture, working on lighting, texture mapping, and on the set ensuring that the exact measurements are maintained. So this is way back in '93, people were already thinking about these things. Then the whole World Wide Web came along with VRML, and we've got this description of cyberspace from William Gibson, and it's from his novel called Neuromancer. And this is what he defines it as: cyberspace, a consensual hallucination experienced daily by billions of legitimate operators in every nation, by children being taught mathematical concepts, a graphic representation of data abstracted from the banks of every computer in the human system, unthinkable complexity, lines of light ranged in the non-space of the mind, clusters and constellations of data like city lights receding. It's a very poetic definition, but he doesn't take into account that this whole cyberspace exists outside of networks also. It exists on your home PC, when you have these games you're playing, or it exists on your Nintendo 64 or your PlayStation game console. So there's a lot of other places that these things happen in. One of the reasons why we keep getting hired as architects to work on some of these games, there's a very famous game called Zork Nemesis that we worked on, and we're actually working on the sequel to that. Just really simple things like, if you recall William Blake's words, when the doors of perception are cleansed, man will begin to see things as they truly are. In computer graphics, we're working in reverse. We're trying to cloud the doors of perception, to dirty up the space until you reach a point where you go, yes, this is believable. The problem with a lot of computer-generated renderings you might have seen is they're very clean. There's no people, there's no dirt, there's no litter, it's too clean. So that's what we're sort of trying to come up as with the architectural design twist to all of this. Make it real. Make it believable. It might be something as, simple as, handicapped, as ramps for handicapped people to get into a stadium, or it might be something as subtle as braille lettering in a virtual elevator going up and down. You don't actually notice these things when they're there, but you notice them when they're not there. Your eye goes right to it and say, gee, that's missing. It was very funny because we were working on this vertical reality game, and one of the door handles was not at 3 feet. And so one of the designers pointed that out. Gee, that door handle is actually at 4 feet. That doesn't quite work. It's very simple, but factual accuracy in a design actually works a lot better. Initially, a lot of the design work we're doing, we're simply making similes of reality. We're taking existing spaces and recreating them. There's racetracks we're recreating. There's stadiums you saw. Those are for baseball games. But as we're doing this, the class that I'm teaching this year at USC, we're displaying some of Julius Schulman's photographs in a 3D gallery on the web, right? And so they're designing these galleries, and all of a sudden we're thinking, well, we don't really need an exit for this, do we? So there's all these different changes in design perception that are starting to occur as we get used to the medium. Initially, a lot of psychological studies that have been done for virtual reality have shown that people get very disoriented in these virtual spaces. So one of the things that I'm researching along with my company is human computing interfaces that don't involve immersive headsets, where you don't feel sort of trapped with this monitor that's on your face, but more with using your body to move through space and interact. And we're doing some experiments with music. We're working with a musician that used to play for a band called Yes. So he's got a studio in our offices, and he's used some of our technology. We have this motion sensing technology where you can map sounds to a space. And as you move through the space as a dancer or just moving through it, you can create sounds. And if you know how to play the space, you can create music. And I'll show you a videotape of some of that as well. So what I'd like to do is show you another videotape which will show you in its entirety how we work with these musicians and how these things mean in a business sense. Because all of this stuff is great conceptually and theoretically, but you've got to be able to make money at it. You have to make a living at it. Unless you're actually making a living at it, I don't have a patron that's paying me to do this stuff. I have all these employees that I have to pay. So let me show you the videotape, and we'll show you some of the applications, the commercial applications we're putting together. The tape actually is a financial piece that was done on our company by CNN in November.
This is Managing with Blue Dogs. Good day and welcome to Managing Interactive Life, where in its first 6 years, this company was strictly R&D, trying to build a product around proprietary technology. But now they've gone to market with a real home run. Steve Young has their story.
Batting like a champion, just a pocket full of quarters away, aren't these guys? They're paid to test home run derby, the first gaming application of interactive lights involved in smart gaming technology. Originally thought of as a sensor for elevator doors, it's used here as something to knock sales from the upper deck by turning the average Joe into a long ball hero.
It's been incredibly successful. In about 95% of the locations, it's the #1 earning game on site, earning anywhere from numbers from $800 a week to all the way up to $2,800.
Instead of pushing buttons, then you swing a bat, like in real baseball.
Instead of buttons and joysticks, we've eliminated those using our patented core technology of infrared sensing, measuring the velocity of the bat, the slope of the bat, the angle of the bat, all based on timing and height of a 3D ball coming in.
Home Run Derby is the lead-off hitter for what the company hopes to build into an all-star lineup. The beams of their killer application is targeted at musicians.
It's pretty blown away. It was weird at first. I was like, wow, I'm just moving and making sound. So it was kind of tricky.
Basically, the computer is recognizing a MIDI signal, which is the musical instrument digital interface, which all instruments speak to each other, not all electronic instruments, and some more traditional instruments. And it's turning it into a signal to advance the switcher through a series of chords, Beethoven's Fifth.
Company CEO Amir Rubin brought the technology to the U.S. from Israel when he headed off to Columbia University. But he dropped out and went right into business, selling a line of children's books through Toys R Us.
My overall strategy in business is to team myself and to share the potential with big and powerful players in every industry we go for.
People he met in the toy business led him to some investment banking heavy hitters. They saw the light in building a business around Rubin's unique technology.
I mentioned bring in leaders of institutional market, the institutional market, everybody from lifestyle companies out there, many universities and conferences.
He was lucky to Bear Stearns technology partners that he found more big lead investors, most notably an entourage from Blockbuster Entertainment, including billionaire founder Wayne Heisen.
They fell in love with the technology. They said we need this in every one of us, every one of our stores. Next thing happens, they wire a lot of money straight into our account.
Deep pockets have been crucial in funding the R&D stage, including helping the company to acquire a 3D design firm.
When we did our due diligence and then also the maps and all the different people that they deal with, it was like, wow, you guys know a lot of people, and these people can help us grow this business.
They moved in my office and I took position of 51% of the company. And someone then I understand what it means they get.
An example is big gaming games like Call of Duty and others in
Stay with us for more Interactive Lights plan to fund its future and to learn why 3D thinks it was good business to partner with here. Managing with Blue Dogs, brought to you by Merrill Lynch. For our clients, the difference is planning, the difference is Merrill Lynch. And by Sprint, the communications company that moves as quickly as your business. With Sprint, you can be there now.
that's just sort of a background on how the business operates. We have, technologists, artists, programmers, everybody working together to build these interfaces. And you saw how the music part of it worked too. It's very interesting because we have all these talents in-house. If you're making a game, you can actually test the hardware, you can write the code, you can create the art and do the music, which is also part of the experience when you're moving through the space or interacting in the space, all in the same place. And it's really interesting because we're going back to the Renaissance model, as we talked about, where you have all this interaction between all these different arts and disciplines that really ends up, coming up with a great new product. What I was showing on the computer screen as I was moving through the space, there was a very blocky sort of an interior that we were moving through. That was a project we did for Bank of America a year and a half ago, and it was a proof of concept of a 3D bank on the World Wide Web. What they asked us to do was design a user interface which was much more intuitive than all the forms that you can use today for online banking. So we tried to devise a whole new language. For instance, what is it that you waste your bank's time with? What they term as wasting their time is calling them up and saying, well, how much money do I have in my checking account or my savings, or how much money do I own my car or my boat or what have you, or my MasterCard. So we had this room where you walked into, and instead of actually having to talk to people, you would click on these icons, and then you would send, the bank server would then send that information back to you. And that's what I was talking about, having similes of reality rather than metaphors, because even though this medium allows you not to worry about things like, well, you don't need to have a roof, or you don't need to have, up or down, because there's no concept of up or down. It's visually very disorienting. So as we start getting used to this medium, we found it's better to start with an approximation of reality and then take that concept a little further every time. And so it was a very interesting design exercise, because there's all these things that we were learning about, that we kept doing what we called focus groups, and it's funny because if you have the browser going too quickly, then people will get nauseous, things like that. There's a lot of these really interesting things you have to consider when you design all these games. I remember working on a simulator for Six Flags Magic Mountain. It was a ride where you were actually in these spinning flight simulators, and so you felt the G-forces, and you flew through this canyon. And what we tried to do was keep the pitch, fairly gentle, because you had these really expensive pods, and you didn't want people throwing up in them. So there's a lot of things like that you end up considering. Anyway, so in the future, entertainment is just the way that we're pushing all of this stuff now, but there's a lot of other applications. So Georgia Tech, they're experimenting with 3D virtual worlds to cure people of agoraphobia, which is the fear of heights. They're having them go out into these virtual worlds and slowly, taking them higher and higher so that maybe they don't feel as afraid anymore of heights. Researchers at Loma Linda University are working with people that have Alzheimer's disease, where they lose all their motor function, and the only thing that they can actually move is their eyes. And so they have these sensors attached to their their eyelids, and as they move, they can move through these virtual worlds. It hasn't physically improved their condition, but their mental state is much better because they at least have some sort of freedom of movement there. History, of course, has all kinds of interesting things that we can do. We can recreate history. We can preserve today's history for tomorrow. UCLA has an interesting project that they've been working on for years, where they have an entire real-time database of Los Angeles with all the building facades and everything plugged in. So people can go over there and plug in their building into this database and see what it's going to look like. Somebody in the next century, this is computer data. This is XYZ coordinates and how they're connected together. This information is translatable into the next century and the next century and the next century. That does not change the physical depiction. So history, entertainment, medicine, there's so many different applications to this. It's amazing, and it's very exciting because all of a sudden you've got this whole new field opening up, and a lot of you people may end up in these fields. And so I just wanted to. It's almost like I've become like a crusader trying to make people aware of these things, because it's amazing how many architects have been calling me over the last few years. I've been written up in a lot of trade journals and things like that, and they're all like, well, how do we get into this? For a lot of them, it's sad because I can't get them into the profession or give them any advice to get in, later on at a later stage when they're, when they've been at it, 15, 20, 30 years. It's really difficult to change the mindset. I'm going to say a couple of things here that are, that may be taken as heresy, but I'm still going to say them. Design for cyberspace tends to be, you have to be like a chameleon. You can't have your own distinctive design style and say, gee, this is how I design and this is the way it looks, and if you don't like it, tough. Well, if I say that, I'm not going to get my next job. You end up working more, you're much more like a chameleon, where you work with Jim Cameron. He's got one style. We just finished another project on a movie called Contact, where we worked with another director called Bob Zemeckis, who won an Oscar for Forrest Gump. He was designing this city, which was this futuristic city that you had contact with aliens, and he's got his own way of working. And it's just, every director has his own look. Some people want this happy sort of ambiance, and other people have this really dark look, or this vampire game he worked on. I mean, this one director, he made us paint graffiti on all the walls and all the spaces, and it said the worst things, and I don't even know what rating that game got, but it definitely wasn't PG-13. So it just depends. The other thing is the psychological impact as a designer, as an somebody that's built real architecture. You never actually see your creations go up in a space like the ride at Universal Studios. Millions of people see that, but it'll be there for the next 10 years, and then it'll go away. It won't. The only light that our work sees is the light of the phosphor gun, behind a monitor or a TV screen or the projector light. You don't actually see the light of day, so you sort of have to balance that out. People have different reasons why they go into architecture. The flip side of it is you can have as much fun as you like with this stuff. I mean, there are no restraints, there are no constraints. You don't have to deal with the city, you don't have to deal with zoning codes, you don't have to deal with any of that. And as I said, it brings up all these other different issues, things like, well, you don't really have to worry about, access. For the bank, when we designed the bank, we weren't worried about access. In a hyperlinked world, you don't have to worry about things like an exit or access, because you can, sort of beam me up out of there anytime you want. The other thing we also end up doing especially when designing for the World Wide Web, the design work is much more populist rather than elitist, as it tends to be. I mean, a strip mall, or an apartment building or a bank does not generally tend to be termed as architecture in the profession. However, in the real world, when you walk past a building or through a building, your eyes and my eyes see the same thing. It doesn't matter if you have $1 million and I don't. We both see the same thing and we both experience the same thing. However, when you're dealing with the net and cyberspace, the amount of resources you have at your disposal will definitely color the quality of your experience. If you have a faster computer or a better computer, you're going to have a much better experience than someone with a very old, slow computer. So those are other issues that you have to think about. Anyway, I think I'm probably running over time here. I'd like to wrap this up with letting you guys know that there's all kinds of opportunities out there for people that have the inclination. Remember, in this profession, most of us look for people that are artists and that can conceptualize first. Okay, the computer is just a tool. It's like this pencil in your drafting board. The computer comes much, much later. If you can't think, if you can't design, if you don't have a good sense of aesthetics, how well you can punch those buttons on that computer doesn't matter a damn. You just can't do anything with it. So that's very important to consider, and I think it's fine, and because the advance in technology has actually brought people to realize that. In the old days when you had Pac-Man, well, how pretty can you make a little round sphere that goes around eating other little spheres, It's yellow in color. Gee, that's about all you can do. But today, you've got, amazing amounts of computing power. You can buy like this PlayStation that I remember when we bought our first Silicon Graphics computer, it cost us $28,000 in 1993. I've got a PlayStation today at home for $199 that has the very same processor 4 years later. So you've got those sort of resources. So the consumer, which is eventually where all of this is going to, is obviously going to buy something that looks good. It has to be designed well. It has to work well. It has to look good. So that's when all of a sudden all these companies have realized that content and aesthetics and design is what actually ends up selling a product. So that's very good for all of us in the design profession, because all of a sudden, they're not saying, well, gee, why should we pay you for design? I've had that said to me when I was working in architecture too. When you're doing house remodels, your clients don't realize why they need to pay you as an architect. It's like, well, you can't conceptualize this, I can. That's where my value is. I'm going to tell you what looks good because you're not that well trained. You can have a gut feeling of what's good and what isn't, but I need to show you several different things so that at least you can narrow down your choices. Anyway, so that's sort of the end of what I have to say today. Questions? I'm sorry.
Just so as you go off, as you leave, sort of peel out of here, before we start our discussion now, I'd like to tell you that Sandeep will have lunch in the cafe, and then we go around to any studios that you'd like him to visit. So if you need to leave and go do something, but you'd like him to come to your studio, just put on a piece of paper the number of your studio and who's teaching it, and then we'll contact you and come around. So spend some of the afternoon here at school, so you have a lot of opportunities to interact with him. So that's at the cafe, and then if you would like him to come to your studio, let me know before we go. So now let's just open discussion.
Questions? We tend to use almost every program there is out there available. We end up writing our own because once again, the tools are not important. It's what you do with the tools. Alias, Wavefront, Softimage, Form Z, 3D Studio, AutoCAD, just all of them. So, anybody else? Great. Well, thank you all for coming. It was sort of nice coming back to school. This is the first time I've been to this campus. I went to school at the other campus on Berkeley Street. This is a lot nicer than the other place. So thank you very much.